Hi, my name is Christophe Demazière. I'm a professor at Chalmers University of Technology in Sweden. I would like to introduce a technique I've been using for favoring active learning in coding and programming tasks. I've been teaching for many years, and I realized that it was always difficult for the students to apply the concepts they were introduced. This is particularly challenging in the area of computational physics, when the students have to implement numerical techniques, algorithms to solve physics problems. And typically the students are left on their own to make the practical implementation of those techniques. Therefore, it is important to develop instructional scaffolding, which is building a strategy so that you provide the right course elements when the students progress in their learning. For this purpose, I use a flipped classroom, which is having a learning sequence delivering course elements at different moments. It starts with some pre-class activities, which are typically studying some lecture notes or a book chapter. Then associated to that, there are some webcasts, some short video lectures that are recorded, which are aimed at extracting the main features of the books or the lecture notes. Then some quizzes on which the students have to train to further process the content. Then come the interactive sessions where coding programming takes place and the assessments are based on those coding sessions. And then finally, the students are given some time to complete the assessments. So the core of the interactive sessions are based on coding programming, and I used to call these sessions active coding sessions. I use MATLAB Grader, which is a product from the MathWorks. It is a web-based interface for coding. You provide a structure, a template of the codes, and the students have to work on this template to complement this template to find the right answer. And there are also some automatic self-assessment tests you can design so that the students can test themselves their code. So the interface looks as follows. You have a description of the problem, then you have the main part of MATLAB Grader, which is the functions or the scripts or the coding that the students have to work on. Then you have also access to a terminal window in which the students have access to all MATLAB functions. And then finally, this self-assessment test that the students can run themselves and see whether the answers are correct or incorrect. So MATLAB Grader was used as the way of assessing the students. And some takeaways from this technique, where you directly interact with the students. The students are deeply engaged in the activities, therefore they develop much higher order cognitive skills, they learn much better. You are also there as a teacher to support the students when they most need your help. The interactions are also continuing after the interactive sessions. And finally, you have a better alignment between the learning objectives and the assessments themselves. Thank you for your attention. In case you have any question, don't hesitate to get in touch with me.